Hi everyone. So today we are going to take up a topic that deals with the classical ML algorithm called isolation forest. I already had a short video created earlier on the same. So here the business problem that we are trying to address is it's something common across all the domains. So we are going to deal about how we can use a LLM or we are specific the classical ML model here to determine the anomaly that we figure out in the logs. Just to keep it simple, for any of the operation, any deployment or any tracking, any application or monitoring purpose, we generally start with looking from the logs. And sometimes we get into an issue where the log turn out to be like intermittently we are getting some unexpected values that we classify as anomaly. The tedious task here is like to manually monitor all the services and keep on tracking for the outliers so that we can figure out the root cause for the same. So this is something that will help in root cause analysis. Without doing further delay, let's get started. So here we are trying to visualize all the services that comes into my workflow as a node of a topological graph. So it's something like a dashboard wherein all the services are represented as node and all are interconnected. And how we are leveraging the model here is by for each services. Here say by service I'm referring to interchangeably with the node. So for each node we'll have a corresponding call made against the logs that we already have in the system, and it will determine the anomaly across the same. So before we get into the log, we'll just try to run the application and see how it appears. Then we'll dig down into the deep understanding of the same. So this is a Streamlit based application. We are at the end we are using the FastAPI to do the parsing of the payload, the request body that we send across for each service. We'll get into the same in some time, but let's start the application first. So I go to the location. So we start the application. Streamed run anomaly dashboard. It's supposed to start the dashboard. So here we are intending to figure out the anomaly. Now this is something that could be scaled across the different subdomain. Now here I have deliberately taken the analogy for each of the subdomain across in an organization like service 1, 2, 3. Or hypothetically, we can map it to something, an application or the subdomain. For instance, say in the banking domain, it could be something, one service that is related to deployment, one is that related to the development and of one is only for monitoring, the third one is that some dependent service. So if you see, we can choose either of the services here. Let's start with the one. So the default we get here is like 3 services we have. So we do have a provision to add that. That is something we can scale the application. But for the demo purpose, I have kept only 3 services here. So the service A, B, C correspond to node 0, 1, and 2. So from the user perspective, what he's supposed to do is he just need to look for the CSV file format of the logs that he want to analyze. This is something as a batch process of analysis where we are not pulling the logs from our centralized system, for example, the Splunk, considering there could be an overhead of continuous polling. However, that is also provision. But for now, we have kept downloaded the CSV file for the logs. Now, if you see, I've taken one test log here. So it will show us the logs we uploaded. It will give us the preview of the same. So in the log that we captured, we have the response time, CPU usage, memory, log level, and status code. Now, considering the scenario wherein we are suspecting there is some latency in the application. So how do we map that? We generally map that with the response time. Means we are expecting some of the cases we might be having outlier where the response time is something not within the acceptable limit. It is something on the higher end. So considering that, so now this is something, it's based on this scenario. Now, in case suppose we would have seen some of the issue with like out of memory, then we must be suspecting there is some CPU usage. Then we could use that feature. Now, one of the advantage of using this topology here is whenever we are uploading the CSV, we have the corresponding feature that we can select for. Now, why we want to select this feature is we want to see the anomaly if we have any across that particular attribute. So here we are checking it for response time. Now, if I see the response time, I give a threshold value. I'll come to threshold value in some time, but let's see how when it trigger what response we get. So I'm getting failed. Why? So the reason being, I'm making a call, API call to my fast API that have yet to start. That is something which is in turn, it's we can utilize like an API service that will be reading this payload. So payload or the request body would be this value threshold and the feature or the parameters against which we want to figure out the anomaly, and that will use in the and once it receives the value that fast API, it will use the IsolationForest machine learning model to figure out the anomaly. But before going into that, let's start the service. So we have a service. We start with the. It will be starting on port 88000 as expected. Now, if you see, application has started here. Start completed. We'll just put into the trigger. We get the response here. So this is the prediction. Now, if these are the internal, we can get into the same like what these values are. But mostly you can look into this. If we are getting value as -1, it's something like in the negative direction, something that we can directly map it to be an anomaly. So let's just look into the solution. So it says analysis found. We found one anomaly. We got the anomaly result that is done by the machine learning model we had at the back of the our first API. You see so this is the anomaly. So why is this the anomaly? Because here when we check from the response time, this is something on the very higher end. If you compare other values, let's sort it out with the time. So this is one of the higher anomaly. Now why we got one? If you see, we must be saying, okay, we are getting 84, 67. Most it mean it looks like around 300. Even 452 should be an anomaly. Yeah, that could be an anomaly that we'll see. That depends on the threshold value. If you go with the 0.1, let's see what we get as a response. So here the number of anomalies is again still 1. If you see here, we got anomaly 1. And if you increase the value to 0.2, what anomaly we see? We against see 1. So this depends actually how we want to allow the contamination rate. Something like when a user expects, consider a scenario, in a flow, we do get a high response time, and then in that case, what happens is certain in some of the cases it's acceptable. So assuming like 10%, or like to be very optimistic, the 1% is of response time to be on higher end is accepted because of the system flow. We can go with the 0.2. If we get something more than 20%, then it's a point of concern for us. Taking another use case, maybe we can switch the feature. Let's take the CPU usage, then we'll see how it behaves. When we are tracking for the CPU usage, we see we again got the one anomaly. And what is the anomaly? That we'll see here. That is predicted to be 49. That's predicted to be 91%. So in this case, it looks more realistic. But we are still able to accept. Let's sort it out. 82 is still accept. If we are just considering on the threshold to be like top 10%, rest we are okay, like it might mitigate with time. However, if we are more concerned and we are more suspectable, like it should not get into downtime, we want to do proactive measure, so we might capture more anomaly. Let's see 0.1% if it's accepting. Here also we are getting 1. We say 0.2. Okay, so probably the flaw here is we are checking only, we are sending the contamination, but we are not passing it to the to our model basically. Or another way we can check it, like it's a multi features. If we go with the memory usage, for instance. Now we'll see how it works. Now it's giving me one. What we can do similarly, we can try with the another. Let's do one thing now. Since assuming we got only one anomaly and we are okay, because this anomaly sound looks like okay, it's not very frequent and we are okay with the time. We can continue our flow. We click on the continue flow. This value is something accepted. It turns green, means we are okay with it. Now how it helps, like we are centralizing all the application at a one dashboard. We need not to ask user to manually monitor the anomalies or continuously monitor the log for any error, but rather we can just click on this, or a single person can configure and look for another one. Now if we check for another one, so we are checking for service B, and let's upload some different sort of CSV file. We can check for some other CSV here. Or maybe we can just simply create the, we'll leverage the perplexity here. So just create to create me the CSV file that is something analogous, but we'll have more anomalies basically and more features to figure out the anomaly for, and more option for user to select the features to figure out anomaly against. So what we'll do, we'll just take this as a reference. Okay, probably what we can do, we can simply ask that. So we can ask to create a CSV file with head CSV file with logs sample from Splunk having anomalies for a feature called high backend response. Let's see if it's great. We can use leverage this to run and validate the application. Because the advantage of this app is basically you need not to do any manual configuration. You just need to upload the CSV. It will give you all the features, and based on the feature, it will predict the anomalies. Let's take it for some of the example. Now here we got one sample file, very high anomaly for the responses. We'll leverage this one. Splunk log high backend response CSV. So let's upload this one. So if you see, we have loaded, and what feature we are getting here, it has got hypothetical host name, backend source, JSON, and backend response. If you see, backend response also has some of the anomalies here. And we have an option, which one we can select for the backend response. And now the percentage itself is something on the lower side we want to see. How many anomalies? It's finding us the 6 anomalies. Now, if you see the 6 anomalies, how it categorizes the 6 anomalies. So all are marked as -1 prediction, means they are on the negation side. And if you see the response time 120, 112, 227 looks lower end, and all 800 are on the higher end. So this is based on the 0.01. Now had I taken 0.2, how many anomaly I figure out, I'll still get the 6, because if you see the backend response is something on the higher, it's exclusive on the higher end. If you see here, yeah, the top 6 only we are finding that is on the higher end, or these are tricked as -1 on the something that is not acceptable. So this is the baseline. We have provision we can continue flow. How we got some error here because of the some code probably. But okay, this is something where I'm intending to generate the PDF. That is something anyway we can fix later. That was nothing but was trying to capture the anomalies in the PDF, but the same we are seeing on the in the UI as well. So let's try it again. We'll just try to retry the same thing what we have done here. So we got the view again, we select the feature, but this time we'll be selecting, suppose we select the host. Do we have any anomaly in the host? So zero anomaly. Why? There's no criteria that will differentiate basically. All are host 1, all are like host 5 or host 4. Means all are almost have equivalent probability, so that doesn't turn out to be an anomaly. That is one part actually. It's not giving any false positive. However, if we consider some another parameter, let's take another parameter when we'll be taking, let's status if we take. What do we get into status? Zero anomaly. Why so? The reason being all are status 200. So we'll do one thing. We can quickly, for illustration, to quickly change the test status codes. Let's see. It would very simple and easy use cases to figure out. Let's see. Assume we get some issue here. Wait, did I save it? Didn't save it hopefully. Okay, let's do one thing. I'll save it again. Suppose I get 500. Let's add some more value for 500. So we're gonna save this. Okay. So we'll be saving this again on the dashboard Splunk high log. We're saving it on the desktop this time, and let's try the same functionality here. We'll keep the feature status only, but we'll browse the file again, but this time from the desktop. Okay, probably I should have saved it as a CSV file. Sorry for the repeated updates doing on fly. I can save testing CSV on the desktop. Okay. Now if you see here, we got the response. So sorry, we have uploaded the JSON that we want to figure out. And see if what is the, okay, just give the preview. Now we'll select the status and we'll trigger the analysis. So here, do we see any anomaly? No. Reason being, okay, the thing is we haven't uploaded the correct file. Let's do once again. We'll close this one. We need to go to the desktop actually. Okay, so what we can do, let's open this with text editor. We'll just change here 500 randoms response. We'll put one response here 500. We'll save the file. We'll upload the file again. So yeah, from this is the modified file now. I think in the preview we can see that one. No, okay, let's do it then. We'll check it with the status. So if we trigger, see something, again we are getting 0 the response time despite having 200 the status code. We don't have any, okay, we have 500, okay. So the problem, the thing is, it doesn't turn out to be anomaly because we have multiple 500 that appears to be unexpected. So we'll do one thing. We'll edit the file. We have got 12,500. So what we'll do, we don't have any 404. Let's check it out. How many 404? Let's check it. Check this here. Just 2. So we are expecting this time we should get 2 as an anomaly. See, this time I didn't select any of the feature. It's giving me 6. Based on what? You see here, this is giving me the anomalies generic based on the backend score. However, if I select the status, it will give me 2 anomaly that we were looking for. Now, if you see here, the anomaly that is predicting as anomaly are again the value where we have 400. So this is the baseline. So this is something we can extend now. If we extrapolate this, we'll be getting a feature. We can simply do a provision to add the new service as a node. And if you visualize, it can scale up to thousands of the nodes. And one more thing we can do, we can quickly, let's see how many entries we have in this file. So if you see, for a person to manually to check for all the entries and figure out, maybe a person can say, okay, we'll simply do Control C, Control F, but that's a manual effort. Here we are not doing that. And now imagine when it's scaled to thousands of services, how tedious task it would be. And one of the use case where we can save a lot of time is like when we are doing blue-green deployment, we deployed one service, and now for instance, let's service A has been deployed. Now we want to deploy service B because service A was a prerequisite, and we deployed service B also. Then we realized service A has some issue. So herein we can figure out the anomaly in service A doing continuous polling using the AI ML model that we've used in the backend, and it can scale up to 7,000, 10,000 of the entries in one go itself. We can do one thing. We can create a big file and we can see how scalable it is. 10,000 entries. Let's see if our perplexity model is too good to create. We'll just create that one. And in the meanwhile, I can show you what exactly our code is like, what to do. If you see, this is the Python written in Streamlit. We have all the UI done here. It will be making a call. It will be making a call to REST API that is written in API. This is a fast API, and the fast API is something that is intentional. When we are calling the endpoint, we are calling predict. So here, this is one of the offering, but we are calling predict CSV because we are uploading CSV file also. So herein, eventually, whenever it's taking all the parameters, it's reading that file that we uploaded, and this fit predict is the actual method that will be called. If you see, this is being called on detector. Now what detector is? Detector is nothing but it's a log anomaly detector that is coming from our anomaly detection isolation forest. So this is log anomaly detector. The whole magic is being done here. If you see, cell processing features. It's reading the CSV that we have given and isolation forest. If you see the crux, the meat of the application is here. This is what it's able to do the prediction on its own. It's a pre-trained model. You have to just use it. What parameter you need? It needs the contamination. So contamination, as I initially told, by contamination we are here. What we say, uh, threshold. So this contamination is something where we are allowing, okay, this much of the anomaly is expected, at least. So if there is no anomaly in this range, we are good. If we increase the anomaly to 2%, it's like 20%. If we trigger, we see if here, as of now, we have only two. Now, suppose if you had more thousand, like 1,000 entries with 100 entries to be 404, and we expect an anomaly of only 0.001, then probably we'll not get any anomaly. Because it means having 100 out of 1,000 turns out to be 10%, and we say, okay, 10% is accepted. We are not calling it anomaly. This depends on the business use case. For instance, suppose some of the exceptions we are getting because of a retry mechanism, because of the contention of the service, we might not consider that as an anomaly. In that case, we can overlook this. So that these contamination solely depends on the business use case. So now let's see, we have got another CSV. So we have lots, as per we have 1,000 entries in this one. Let's see how the model will behave here. And this Splunk log backend is from 1,000. CSV is the name. Let's try to configure the third node here. Here also we see we have a lot of options here. Again, we got the backend response. It's the same header actually. Now, how many anomalies? 998 anomalies. So, out of 10,000, how many rows we have? If we look here, the file we are expecting it to have 10,000 of entries. We can open and verify the same. This easily appears to be 10,000 of entries, and of which we are getting anomalies 998, and that is for backend response. And let's see what are the anomalies it classify. Classify the anomalies for backend, so like 104, 101, 102. These all are anomalies. Still, we'll see where the benchmark changes to normal. Now, if you see here, it's able to traverse easily around 10,000 of entries itself. Now 188 to 260 to 244, they consider to be normal. And the other one that we see on the head end, 822, 800. Scroll to the up. Yeah, now one more point that we want to see, it's the anomaly is not always on the higher end. Anomaly is something that's not as per the expected pattern. So it will consider both as anomaly. The lower values, the expected the normal, like normal considered here, it looks like around 300 or something, but we are getting some 100, 200 that are also considered here as anomaly. Now it depends on the how scalable it is. It's not 10,000 rows. We're able to get the scan anomaly of 998. So this is something that will be helpful in the very scalable application. So I hope this video helps. This is something can be scaled more further. We can give a provision to one of the use case could be in the deployment, or one use case just solely for monitoring. We can just integrate the backend of each node using MCP and all that will be covering in the next session. So I think this helps, and these are the major three files. One file that's creating the UI and all in Streamlit. Another is application where we are defining the endpoint using the FastAPI, and it's internally calling a Python file that is nothing but implementing the isolation forest and predicting based on the contamination or the allowed anomaly that we defined from the UI. So I'll be uploading the same on the GitHub repo, and link would be shared there. Yeah. Thanks for being there. Thank you.